Today I'm going to talk about rational numbers. Rational numbers. So put that at the top of your page and put today's date in the top right corner. Let's start off with a couple of vocab terms. Rational number. Well, what is a rational number? And this is kind of a complicated definition, but you'll get the hang of it. It's any number that can be written as a fraction, n over d. And I'll explain what that means in a second. Where n and d are integers and d is not 0. So let's start with that definition. What that means is like 3/4. That is a fraction where the top and bottom, the numerator and denominator, n and d, n for numerator, d for denominator, are integers. Remember, integers are positive and negative whole numbers. So we could have also put like -2/7 or 6/5. Those are rational numbers, any fraction basically. Here's what's not a rational number. 7.21 over 9. Because this is not an integer. It has to be an integer. Also, this could not be, so let me put a little x through that. This can't be an integer either. Or sorry, a rational number. 7 over 0. Because 0 cannot be in the denominator, because you can't divide anything by 0. So again, rational numbers have integers in the numerator and denominator. Also, a rational number can be expressed as decimals that terminate or repeat. Any of these fractions can be decimals that terminate or repeat. Now, terminate means end, just like the Terminator. Okay, it's trying to end you. And repeat means like 1.33333 going on forever. That's a repeating decimal. So that'd be 1 1/3. Okay? So those are rational numbers. So make sure you write this down. Any number that can be written as a fraction, n over d, where n and d are integers, numerator and denominator, and d is not equal to 0. Like these wouldn't work. And then decimals that terminate or repeat. All right, those are rational numbers. Here's what relatively prime means. Numbers that have no common factors other than 1. For example, 18/35. Everything that makes up 18 and 35, well, you could do 9 times 2 or 6 times 3, okay, or 18 times 1. 35 is just 7 times 5 and then 35 times 1. The only ones that they have in common are 1, because 35, 5, and 7, that doesn't appear anywhere up here. So these are, 18 and 35 are relatively prime to each other. So here it says simplify. Now we're simplified when the numbers are relatively prime to each other. For example, 9/55. Well, we can multiply together 3 and 3 and 9 and 1. Here we can multiply together 11 and 5, 55 and 1. That's it. So these two numbers are already relatively prime, so that's already simplified. All right, now, number 2, we want to simplify this. And to simplify this, I always look and see if it's an even number. These are both even numbers, so we can always divide by 2. So let's divide by 2 on top and bottom. -24 divided by 2 is -12. 32 divided by 2 is 16. Again, they're even. Let's divide by 2 again. So we get -6 over 8. Again, even. Let's divide by 2. Divide by 2. So that'd be -3/4. Now, these are relatively prime, because they're both prime, or 4 is not a prime number, but only 1 and 3 multiply to get 3, and 2 and 2, 4 and 1 multiply to get 4, so I know that that's simplified. Another easier way you could have done it is if you know that 8 goes into 24, so you could have done that divided by 8 to get -3, and that divided by 8 to get 4. You could have done it that way as well, but you got to know your math facts for that. Try these on your own. Okay, welcome back. Up top here, we have 16 over 80. Even. Let's divide by 2. You could get 8/40. Again, even. Divide by 2. 4/20. Even again. Let's divide by 2. Let's keep doing it. 2/10. Again. Divide by 2. Divide by 2. You get 1/5. you could have also just gone straight here, and I know that that 18 could divide this by 16, divide this by 16, and you end up with 1/5. All right, what about this? Negative 12/16. I know that 4 goes into both of them, because 3 times 4, 4 times 4, so let's divide by 4. And I get negative 3/4. So that's simplifying. And remember, these are relatively prime now. 3 and 4 are relatively prime. 1 and 5 are relatively prime, meaning nothing else goes into them except 1 that they have in common. All right, write each decimal as a fraction in simplest form. This one throws people off. Here's how you do it. Here's the easy way. Look at the furthest digit to the left, and it happens to be this 9. Now this 9 is in the hundredths place. This is the ones place, right? This is the hundredths place. So I know that it's going to be 59 over 100. Because it's in the 100ths place, I know that there's going to be 100 in my denominator. Now, we have a negative 5 out front, so it's negative 5 and 59 100ths. Now, can we simplify this? Well, we can divide 100 by a lot of things, like 20 and 5, 25 and 4, 50 and 2. But 59, that's a prime number, so we can't. So we're simplified at negative 5 and 59 100ths. Let's look here. This is in the 10 spot, 100 spot, 1,000 spot, 10,000 spot. There we go. So it's going to be 5714 over 10,000. You just take that whole number. And then whatever digit, whatever place value this last 4 is in, what the last digit is in, that's what goes in the denominator. It's in the 10,000 spot, we put 10,000 in the denominator. Now, these are both, this ends in a 4, this ends in a 0, so we know that they're even. So let's divide by 2. Well, I know 10,000 divided by 2 is 5,000, so put that on the bottom. This one's a little tougher, though. So let's do what we did during bell work. No calculator here. 2 goes, so it's 2,857 5,000ths. And that ends in a 7, that ends in a 0. Pretty reasonably sure that we're done there. Try these on your own. Okay, welcome back. Here we have 5 goes out front because it's 5.37, so it's 5 and something. This is in the hundreds place, right? So it's 37 100ths. And 37's prime, so I know I can't reduce. Here, tens, hundredths, thousands place, so I know it's 622 thousands, okay? And there's nothing in front, so there's no whole number in front, it's a 0. Let's divide that by 2. Now, real quick, 2 goes into 6 3 times. 2 goes into 2 once, 2 goes into 2 once. We have 311 over 500. And there we go, simplified. Again, put the last digit, the place value of the last digit in the denominator. Now, what about these? Well, the easiest thing I can do here is pretend it's like a quiz or a test. Here I see 5 over 4. Write each fraction as a decimal. 5 is bigger than 4, so the numerator is bigger than the denominator, and that's okay. I just know that it's going to be a whole number. It's going to be bigger than 1, because I know it's... We are going to put the 5 inside. Sorry, whatever goes on top goes inside. And we divide. Now 4 goes into 5 once. 1 times 4 is 4. Subtract. We get 1. 4 goes into 1. Uh-oh, 4 doesn't go into 1. We need to bring something down, because we can't just do numerator. We can't just do a remainder, because we're in 8th grade now. So we're going to do a decimal. 0.5 is the same as 5.0. So let's do that. Bring down the 0. So now that 4 goes into 10. If we have a decimal here, we have to bring it up into here. So that becomes 1 point something. 4 goes into 10 twice. 2 times 4 is 8. Subtract, we get 2. So bring a 0 down again. We could keep bringing zeros down all day, because 5.0 is the same as 5.00, which is the same as 5.000. 4 goes into 25 times. 5 times 4 is 20. Subtract, I get 0. Subtract, I get 0, and I'm done. 1.25. And look, we knew it was going to be over 1 because the numerator was greater than the denominator, and we get 1.25. Let's take a look at number 10. Negative 1/6. This one's going to be a little tougher. So 1 goes inside. Whatever's on top goes inside. We'll see how many times 6 goes into 1. We know it's going to be less than 1, right? And I'm not going to worry about the negative and positive here. I know my answer is going to be negative. So this is 1 divided by 6. So 6 doesn't go into 1, so I'm going to do my 0.0 right now. And remember, bring that decimal up right there. So we know it's going to be, 6 doesn't go into 1, so I'm going to put a 0 there. It's going to be 0 point something. 6 goes into 10 once. 1 times 6 is 6. 10 minus 6 is 4. 6 doesn't go into 4. Let's bring down another 0. 6 goes into 46 times. So 6 times 6 is 36. I get 4 again. Well, let's bring down a 0. 6 goes into 46 times. 6 times 6 is 36. Looks like this is going to keep happening, right? Another 40, because we can bring down another 0. Look at this pattern. 0.1666. It's going to go on like that forever. So we can do this, 0.16 with a line over the 6, because we know it's repeating. And remember, from the definitions earlier, a rational number, decimals that terminate or repeat. So we know that this is a rational number because it's a repeating decimal. Okay, 0.16 repeating. And remember, that's negative, so it's negative 0.16 repeating. Okay, try these two on your own. Okay, welcome back. This is the same, remember, as 11 divided by 9, so we'll put 11 inside and 9 outside. 9 goes into 11 twice. 2 times 9 is 18. Twice. Sorry. Okay, welcome back. 9 goes into 11 once. So 1 times 9 is 9. We subtract. 11 minus 9 is 2. 9 doesn't go into 2. So here's where we put 0.0. We could do that all day. Put a 0 down here. Make that 20. And whenever we put the decimal down here, we put it directly above up here. We have to make sure these are perfectly lined up so that we do the decimal right and we do every place value right. 9 goes into 20 twice. 2 times 9 is 18. Subtract, we get 20. Sorry, we get 2. But we need to bring down the 0, right? Because 9 doesn't go into 2. 9 goes into 20 twice. We get 18. We get 2. Bring down another 0. We get 20. It's going to keep going, right? So you could get 1.2 repeating. And again, that's a rational number because the 2 is repeating. It's 1.2 repeating. And I knew this was going to be over 1 because the numerator was greater than the denominator. Like in number 12, I know the denominator is bigger than the numerator. So I know it's going to be under 1. So let's see. So how many times does 20 go into 7? Well, 20 doesn't go into 7, so I'm going to make my decimal right there. Bring the decimal up. So 20 doesn't go into 7, so that's going to be 0. 20 goes into 70 3 times. 3 times 20 is 60. Subtract, we get 10. 20 doesn't go into 10. Let's bring down another 0. 20 goes in 100 5 times. 5 times 20 is 100. We get 0. So I know that we have 0.35. And again, that's a rational number because it's a terminating decimal. Terminating means stopped. Okay. To review, rational numbers, any number that can be written as a fraction, like with the integers, the numerator and denominator being integers, like 3/4 or negative 2/7. Here's what's not a rational number. Pi is not a rational number because it goes on forever. Okay, 3.14157, whatever it is, it goes on forever, so that cannot be a rational number. And then relatively prime, two numbers that don't have any factors that are common besides 1.